Assalamu alaikum, everyone. Welcome to our webinar Introduction to Scale Management by Engineer Muhammad Askar. My name is Abdullah Abdurrahman. I am a business developer in Reservoir Solutions. I would like to make just a 5 minutes presentation about Reservoir Solutions company and also to introduce Engineer Muhammad Askar. So Reservoir Solutions is a company specialized in providing technical studies and courses for oil and gas companies and professionals. The company incorporates many professionals with diverse technical background related to oil and gas exploration and production. Our services include technical reservoir studies, field development planning, reservoir static and dynamic modeling, economic feasibility studies, technical support for academic researches like PhD and master degrees. Also, we are assisting in writing technical papers and publishing. We have technical petroleum courses by industry expertise. We are providing mentorship programs. So about our instructor for today's webinar, Engineer Muhammad Askar. Engineer Muhammad Askar is a well integrity management engineer at GAPCO company in Egypt with about 12 years of experience through a diverse exposure to the oil and gas industry by taking the responsibility of different roles like well integrity management, scale management, offshore logistics, and field development technology engineer. He participated in several national and international reputable industry conferences. Now he is doing his master degree in petroleum engineering in Cairo University. So we would like to welcome Engineer Muhammad. About our webinar rules, please, if you have any questions, you can drop it into the Zoom chat and instructor will answer them at the end of the webinar. Please mute your microphone and camera. In case that you want to have a certificate for this webinar, you can fill into the form that will be sent into the Zoom chat. For upcoming events, you can join our Telegram channel and also follow our LinkedIn page, and you will find the events announced there. So you can also contact us through the mail and the WhatsApp. So thank you all, and Engineer Muhammad, you can start me. Engineer Muhammad, do you hear me? Okay, so just we are waiting for our instructor to share his screen and open the mic to start the session. Engineer Muhammad, you hear me?
Hello, Assalamu alaikum.
Alaikum assalam wa rahmatullahi wa barakatuh. Okay, Engineer Muhammad, you can start now.
Okay, thanks a lot for waiting. Thanks all for being with us in this webinar. I'm honored to be here with you. I will introduce some points about skill management as a petroleum engineer. I'm not a chemist, I'm not a chemical engineer. I will show you my point of view about skill management as a petroleum engineer. I have some experience in production technology, petroleum engineering, well intervention, skill management, well integrity management, and I hope you will benefit from this webinar. If you have any question, just write it in the chat, and the World Solutions team will decide if they can interrupt me to answer the question, or the question can be waited for the end of the session. We'll start with our agenda. We will have some introduction about scale, what is the meaning of scale, where we can see scales in our normal life. After that, we can discuss scale types, which are encountered in oil field industry. Then we will move to the factors that will that will make some scale depositions and the stages of scale formation from ions to scale depositions inside your tubing or your pipeline. We have a scale management strategy or a system that should be followed in every company. If you follow it, you will have some good practice and we will prevent scale for deposition, and you can resolve it after deposition, and you can note it, you can evaluate the system efficiency. The normal traditional scale inhibition is the chemical scale inhibition. We'll go through some illustration about the mechanism of scale inhibition by chemicals, which is the most common practice in the industry, and how can you deploy the chemical into your system. After that, we will move to a new topic, which is non-chemical scale inhibition, which is a physical method that you use apparatus or equipment to inhibit or prevent the scale without using any chemicals. We will go through some scale prevention strategies, what are the full method currently in the industry, and some papers that introduce some new technologies. We will end our session about scale removal options. If you already have some delivered skills, what's your options, what's your action to remove these skills? Firstly, you should know that scale is a mineral and organic deposit, which is not a hydrocarbon deposit. If you are facing asphaltene or paraffin, it's not a scale, it's hydrocarbon deposit. Scale resulted from the minerals which are dissolved in the water. Everyone sees this photo in his house, like the heat water heater, his bathroom. If you are taking the fuel out, you will have some scale deposition around the coil. It's calcium carbonate. And if you are using some kettle or filler to tea, you have some carbonate deposition due to the heating effect of the water. For me, as a person, a normal person, I usually use vinegar or citric acid like lemon juice to remove these scales. This is carbonate scales, calcium carbonate scales. We use acid fluids like lemon juice, vinegar, or baking soda. These fluids are acidic. You are now making an acid shock. This is actually the scale you are facing in your house. But scales on the oil field are various types. We have carbonates like calcium carbonates, iron carbonates, and we have other scale types like sulfates, calcium sulfates, barium, strontium sulfates, and we have sulfides, zinc, lead sulfides. We'll go through the individual types of these scales after that. But I'm now transitioning you from the household scale to the industry scale. This is the industry scale. You have some scales inside the tubing or inside the pipeline. It will not be like a pure one, with barium sulfate, with a calcium carbonate. It will be a mixture. It is actual photos from the oil industry. You having this layer of scales, you are facing a big problem. You should use several chemicals. You should use an efficient system to prevent this scale from deposition. This is the actual photo in my company. It's a header joint, which has several types of scales, which hinders the whole entrance of the header and restricts the whole production in the field. As a petroleum engineer, I will start from the formation, from the rock. I have rock grains and I have water flow between these grains. I will ignore the oil deposits, which are asphaltene and paraffin, and I will concentrate on the scale deposits. If you are facing some scales like barium sulfate or sulfate inside the formation matrix, you will see these photos under the microscope. This part is a matrix grain, and this is also a matrix grain. This small details between them is scale crystals that hinders the entrance of oil and water between the grains and restricts your production. This is also actual photos under the same microscope for strontium sulfate scales, which have more roughness inside the formation to promote more scale deposition. If you are having a smooth surface or a clean surface, it will not promote scale deposition. But with increasing surface roughness, it will exacerbate the problem and promote more scale depositions, which will hinder the fluid passes inside the formation. If I move from the formation matrix to the wellbore. This is my tubing from the bottom of the well to the Christmas tree. I will face carbonate scales inside some restrictions. I can face barium sulfate scales at the bottom of the well after mixing of incompatible waters at the entrance of the perforations. After moving up through the completion, we can have some gas lift which goes through from
Engineer
the
Muhammad?
gas membrane. Okay.
Engineer Muhammad, I'm sorry, but the sound is not very clear.
Can you hear me now?
We can hear you, but some noise associated with the sound.
Okay. Wait a minute.
Okay.
Is it good for now?
I think that.
Okay. If you have a problem, just inform me.
Okay, so if you can change the mic, it will be helpful.
Okay. Yeah. Assalamu alaikum.
Yes, it's clear now. Thank you.
Okay. It's continue. You have any questions right now?
Again, please.
Do you have any questions in the chat box?
Not yet.
Okay.
Okay.
For the wellbore, I will face all scale types according to the condition that I am facing in the wellbore. At the bottom of the well, I will have some water sources from different intervals. If you have seawater due to water injection and formation water, you will face sulfate scales at the bottom of the well. So, and if you have some restrictions inside the tubing, like a crossover, like a valve, storm shock, subsurface valve, you will have some pressure disturbance in the wellbore. You will face some carbonate and sulfide scales. For gas lift, I will inject the gas through the annulus to the gas lift membrane. Due to the temperature reduction and the gas stripping effect, I will face also some scale depositions at the operating gas lift membrane. For offshore wells, if I have a good length of seawater, this water will make some cooling for the system, and I will face some sulfate scales at the surface. If I am producing like very saline water, which is loaded with a huge amount of ions, it will deposit scales at shallow depths due to the cooling effect of seawater. This schematic shows you that you will have several layers of scales of every type, including our mineral scale types and like other hydrocarbon deposits which are asphaltene and bark. As a petroleum engineer and chemist, you should evaluate the whole system of the company from the water injection system. This is from SP paper. If you are taking seawater from this point and like pumping the water, the seawater injection into injector well, and this is also the same, injecting water in the injection well. The injection water, the seawater, will react with formation water at the bottom of the well due to the incompatibility issues between these waters, and they will form sulfate scales at the bottom. Due to the travel of seawater in the formation, it will face formation water at several points, and it will react with it and will form sulfate scales that will damage the formation and restrict the passes between the injector well and the producer wells. This is a producer well which is producing 100% seawater, which is this blue color. Seawater blue color, and formation water, the formation time is the brown one. This is using a seawater, 100% seawater, which will have no problem with scale deposition due to no mixing with formation water. But for this lateral well and this form, both waters which are different with ion composition will meet each other and react to form sulfate scales. For the same well, at the header, you will face the mixing of incompatible waters, and for the production lines, for the process facility, for the separator, you will have several conditions of pressure and temperature changes and the mixing of incompatible waters. These conditions will favor and promote more scale deposition. So you will evaluate the efficiency of the whole system, including wells, pipelines, surface facilities, everything. You will be sure that you have no scale deposition which hinders the functionality of your system and which will affect and restricts the flow capacity of your system. To imagine the effect of scale depositions, this is a study for BP. For around 5 years, they evaluated the whole production losses. Like 20% of their losses are related to scale inhibition and removal. If you are limiting scale, you are using chemicals or non-chemical methods, you will pay money. If you are removing it, you will shut down your facility and use some acid and some chemicals to remove it. So, or some mechanical jobs like scratching with slip line or some coil tubing operations. Every operation, every chemical that will be introduced in your system will cost you dollars, millions of dollars, and will make you shut the well, shut the facility for the middle well. So you are losing a lot of money, and you are paying a lot of money to fight scale deposition and prevent their accumulation inside your system. So what is unique about scale? Scale can form everywhere in your system, downhole, top sides, inside pipeline, sub compression accessories, in your separator. This is a challenging process and a challenging aspect for you to fight. Some scales can deposit in light hours. Some SP papers report that some wells can cease to flow during the night. You have some light scale, which is a sodium chloride scale. It can form very quickly during a few hours to block your well and make the well cease to flow. So you should be proactive and prevent the scale from deposition, not to lose your asset. Some scales have low solubility against acids or chemical treatments, like sulfate scales, barium and strontium sulfates. They are very hard and they can't be cleaned even by cold tube. Cold tube operation for cleaning or milling sulfate scales can be challenging and a difficult job for the intervention team to remove these scales. You can face several types of scales, as we saw in the picture of the actual scales. It will be a mixture of various types of scales. You should make an optimum solution, a chemical solution, just to dissolve carbonate and dissolve the sulfate and sulfides and chlorides. You will have a mixture. This mixture is very challenging and very special for you. You should formulate a special treatment and plan ahead a good job for mechanical cleaning, removal of these scales. If you have any scales in the system, you will restrict the flow capacity of your pipeline of tubing. So we'll face some deferment in production injection rates in your company. If scales are depositing in our accessory like subsurface safety valve, it will make this valve leaking or stuck open, and it will promote or make the well high risk well. If you're having oil well which has a much fluid capability and a stuck open or leaking subsurface safety valve, this well is classified as a high risk well according to some policies and integrity standards, and you should repair or make some remedial work for this subsurface, or just shut in the well for planning a good remedial work to restore the functionality of the subsurface safety valve and prevent more scale depositions, which will hinder the functionality of the valve and which will restrict your accessibility to the well. As we said, gas injection through the point of injection through gas valves will make some stripping effect and some cooling effect for the production stream, and we will have some depositions around the operating valve. These depositions may block the operating valve and decrease the efficiency of the lifting capacity of your gas lift system. As we said, if you have more restrictions inside the tubing, you will lose the accessibility of the fuel well intervention capabilities inside the well to make some perforations or PLT jobs. You will have a limitation to increase the well production, and you will lose the well at the end. If you are letting these scales to build more and more and block your well, you are facing several problems for you this well. Some scales will have some corrosion under them, which will affect the integrity of the tubing or pipeline. So as a petroleum engineer, my objective in the company, in our team, just to maintain the well reliability and maintain steady production rate of the system or increase it. If I have some damage, I can resolve with the scale to increase the fuel capacity of the system. It will be good. Scale inhibition is far better than scale dissolving. If I have the capability to prevent or inhibit scale deposition, it is preferred than scale dissolving. If you have some scales which are faced during the intervention jobs like slip line gauging or tubing operation, you should plan a chemical or just operation to remove this already deposited scales and restore a clean and good completion. If you are using scale inhibition jobs, you should optimize the chemical consumption. You should introduce new technologies which to prevent scale inhibition. Every operation now in the industry costs a lot of money. You should make the system very efficient, very effective, with low cost. For acid jobs, which are the common jobs to clean and remove scales, we should optimize the formulation, the recipe of these jobs to prevent the side effect of some iron sequestering agent are used especially for redeposition of iron compounds after a spent acid job. To define the most common scales in the oil industry, we will start with the water soluble scale, which is sodium chloride, which is the salt. Sodium chloride in HCl, the mineral structure is called halide, and it can be cleaned by fish filter. For acid soluble, we are talking about carbonates. The first one is calcium carbonate, which is the most common and famous one in the oil industry and in water industries and in the household applications. This scale mineral have several mineral structures according to the packing of the mineral form of the crystals during the deposition. You will face some different forms, but all of them can be dissolved by HCl or organic acids like HF and other acid types. Iron carbonate, which is called sulfide, can be dissolved by HCl and THPS. This is a biocide chemical. Iron oxide is normally phased in injector wells, not producer wells. In injector wells, you are pumping some seawater injection, which have some traces of dissolved oxygen. This oxygen can react with the metallic iron and form some iron oxide minerals. These minerals can be dissolved by acids or plating agents. Iron sulfide is a new one in the industry with zinc sulfide with sulfide. The three ones can be dissolved by acid like HCl, but with the different degrees. The easiest one to be dissolved by HCl is the iron sulfide, and the hardest one is lead sulfide. You can use some pH-based biocide and cleaning agents, as we said, like EDTA or BTBA. These agents use a different reaction than acids. They are basic fluids. They can be pumped with a huge amount and making some certain time for them to react with the scale accumulations. For acid insoluble, we have three sulfate scales: calcium sulfate, barium sulfate, and strontium sulfate. All these scales can be dissolved by creating agents like EDTA and BTBA, and they have a less effect of HCl dissolving on them compared with carbonate scale, especially calcium carbonate scales. So what are the factors for the scales to form? If I have two waters, two unconductive waters, which will react with each other, I having a high permeability streak, which will accelerate water flow. If I have this is a producer well. If I injecting water in an injector well, the water will get some speed in this high streak, high permeability streak, and will get produced inside the producer well. The reaction between the injection water, which is a seawater, which is rich in sulfate ions, and the formation water, which is the dark green, the dark blue one, which is rich in barium and strontium, calcium cations. You will mix two unconductive waters with anions and cations in every one. The reaction of these waters will deposit some sulfate scales, especially barium, which is the hardest one to deal with at the bottom of the well. If you having some radium in the formation water, which is a radioactive one, it will be the first one to deposit even before barium sulfate. You will face these sulfate scales at the bottom of the well, and after a short distance from the perforation, like in the bottom part of the completion. The severity of sulfate scales is changeable. During the facility lifetime, after for increasing the seawater percentage, you will face different degrees of sulfate scale deposition according to the mole percentage of seawater and the formation water. Everyone will be loaded with some concentration its ions, and their severity will change during the lifetime of the producer well. For temperature changes, most scales will deposit for temperature cooling, like sulfate scales and sulfide scales. But for carbonate scales, especially calcium carbonate and calcium sulfate, more scale deposition will be formed during the heating or increasing temperature. This axis has the solubility. If you are decreasing the solubility, you will have some more scale deposition. For high temperature applications, to increase the temperature in this axis, the solubility will decrease. So you will having some scale depositions for anhydride, gypsum, hydrate. All of them are calcium sulfate scales. pressure changes. If you are reducing the pressure of the stream, the dissolved gases will get out of solution, especially CO2 and H2S. And these gases are acidic. If you treat them from the solution, the pH of the solution will get higher and the solubility of the scales will get low. This is the actual case for my memory. We are facing some depositions at these depths from 5,000 to 6,000 feet. I am using a gauge cutter with a certain type. I just get down. I have some extraction at these depths, getting some jarring down to clean the extraction and detect the extended profile at this depth. But this depth is dominant for me. I am facing this obstruction every time for several years during the production life of this well. We assume that this is the depth of the operating gas depth membrane, which is a point injection due to cooling of gas injection. But after making some gas depth separation, we figured that the point injection is away from this depth. So we revisited the PVT data for the fluids of this well. We found that at this depth, we are facing the bubble point pressure. So this is a depth where the first bubble of gas will get out of solution. And if you are getting some gas separation, you're losing CO2 and H2S, and you're having some cooling effect at this depth. So you would promote scale positions at this depth. So you should study your system, study your PVT data, study your water analysis, study the operation factors and operation conditions of rates and everything about your well to assess the scale problem efficiently. This is the equation of calcium carbonate. Calcium plus carbonate will produce calcium carbonate scales, but for calcium and bicarbonate, you will have some calcium carbonate scales, CO2 and H2O. For CO2, if I remove CO2 from this equation, if you remember the Le Chatelet principle in chemistry class, if you remove CO2 from this equation, the reaction will go in the direction to compensate for the reduction in the CO2. So if are you losing CO2 from the solution to the gas phase, you will promote more calcium carbonate scale deposition, and which is our case here in this one. pH changes. If you have some increase in the pH, the solubility of the scales will get lower. Some chemicals like H2S scavengers are triazine based. If you are injecting H2S scavenger in your system, you will increase the pH of the produced water, and you will decrease the solubility of your scales, and you will face some scale depositions at the point of chemical injection. Reaction kinetics and fluid dynamics. For the most of us who are caring about pressure, temperature, ionic strengths, dissolved ions, pH, but the current development and softwares are dealing about these two factors. If you're having some calcium and some carbonate, and they are reacting with each other to form calcium carbonate scales, they will not react instantaneously and form scale at the same interaction depth. They will take some time according to the fluid rate, according to the temperature, according to the roughness of the surface, the tubing, according to everything in your system. We should evaluate the system as a system, not ion against ion. You should evaluate everything in your system, the dissolved gases, the pH of the fluid. So they are now making some simulations about scale depositions to simulate the actual downhole conditions. So we are moving to this point. I have some ions dissolved in the water. These ions will be paired with each other. Cation against anion will form a microcrystal. This microcrystal will get larger in size and having some more deposition or more precipitation to make the crystal larger in size and larger in weight. This microcrystal will be a macro one. These macrocrystals will interact with each other to form a scale sheath, a scale deposition, which will be deposited in your tubing at a certain depth. This process will take some time, from the ion to the microcrystal to the actual scale division which are facing in your system. You should understand this process good, because if for scale inhibition, if you are using some chemicals, you will interfere in this process, and if you are using non-chemical scale inhibition, you would have a different principle for scale inhibition. So this is the stages, different stages of scale formation in your system. For aging, if you are making some scale depositions, these scale depositions will be layered with other types, and pressure and temperature will make this more hard, losing the water, like from gypsum to anhydrite calcium sulfate scale, will changing the roughness and the toughness of scale which are deposited in the system. We'll explain scale inhibition in a different part after some while, but now as we are talking about the formation stages of scale from ions to crystals, for chemicals, if I'm using a chemical scale inhibitor, this chemical scale inhibitor will interfere in the process and make some delay in the scale formation. It will interact and retard the crystal growth. It will prevent microcrystals from interacting with each other. But for the new trend in the industry, for non-chemical scale inhibition, we are introducing energy. Introducing energy to the ions to promote and accelerate scale deposition in the part, in the solution. My problem for scale is deposited inside my tubing and inside my pipeline, have the rough surface of the tubule. But if I give some energy for the scale ions to make them be like a microcrystal which is floating inside the bulk solution, you should produce this microcrystal from the bottom of the well to the surface to your facility, to your process at the end of the line, without making some scale depositions. You are now promoting and accelerating homogeneous scale deposition, not heterogeneous one. I am afraid that we can face this heterogeneous scale methylation and scale deposition at the walls of our tubings, but if I introduce some energy in different types to the system, will promote homogeneous scale methylation in the bulk of the solution, and you will produce scale like microcrystals, fine ones, which will not harm your system or restrict your flow capacity inside tubing or pipeline. For scale management, firstly, if I have a new well, without drilling, without reducing the water, I don't know the composition of the water, or I don't know the scale problems that I will face inside my completion, inside my pipelines. So I will use a complete water analysis from this well or offset well, and simulating the well conditions in a software to predict what scale type and what scale amount will deposit in my system, to be proactive and make some scale prevention for it. If I have some reducing wells, I can detect the actual scales inside the completion by slick line gauging cutters. If I have some pipeline, I can pick the pipeline by a pig and collect the deposit scales amount at the end of the line. You can put some scale coupons with holes in them just to collect the scale coupon and analyze the deposit scale to evaluate how many holes are plugged and evaluate the severity of scale deposition in your system. Scale sample analysis, if you detect the scale sample and collect a physical scale sample from your system, a downhole or surface, you should analyze the scale sample. By third party or your chemical lab in your company, you will define the ions of the scale. You will define which type of scale you are getting in the system, like carbonic scale. You can dissolve it by acid. If you are facing some sulfate scales, you will plan chelating agent job. If you are facing sulfide scales, you can use some biocides. If you are facing a mixture of sulfide scales, you will plan a mechanical cleaning job. You should know the type of scale to prevent it, to inhibit it, and to make some remedial work to remove the already deposited scale in your system. For scale inhibition, you can make some scale squeeze or some continuous injection of a scale inhibitor just to prevent the scale deposition. While modeling, after scale inhibition practice like scale squeeze, you should model the well, you should track its performance. It needs a resqueeze again, if it needs change the chemical inhibitor. If you are making a good progress in preventing scale, or you are just exacerbating the problem, and you should change your mind to use a new chemical, just a new technology. You should evaluate the system continuously to make this cycle more efficient. This is the well assessment job. If you can't collect actual scale sample downhole, you should monitor your well performance to have a decline in the production rate of the well without any operation problem. This may be due to scale deposition inside your system. Prevention of scale deposition. I can make some operational wise or operational recommended practices just to prevent the scale depositions, like choosing the water sources. For sulfate scales, if you are pumping seawater for injection water to support the reservoir pressure, you are just introducing the sulfate ions into your system. These ions will interact with barium ions, strontium ions, calcium ions, and will deposit sulfate scales. So you shouldn't mix interlocal waters in your system. And if you're having some restrictions in the tubing, you should avoid them. These restrictions will introduce pressure disturbance in the system and will promote more scale deposition. For injection water, you should remove any acids that are dissolved in the injection water, like CO2 or H2S, and you should remove any bacteria in the injection water. This bacteria, especially sulfate reducing bacteria, this will react with the system and take the sulfate ions and some hydrocarbon compounds at the bottom of the well inside the formation and produce H2S. This H2S will react with zinc, lead, and iron cations to deposit sulfide scales. But for injection of seawater, you may use some sulfate removal process or desulfonation of the seawater. You can remove the dissolved sulfate ions in the seawater and inject the water without the sulfate. So you will prevent the intermutability issues between the seawater injection and the formation water, and will prevent sulfate scale deposition. For the chemical prevention, we will talk about the chemical scale inhibitors that are used in the industry, and the new trend, which is the non-chemical or physical scale inhibition. We'll talk about some technologies that are presented in some application in SK papers or some technologies for some companies. For carbonate scales, you can prevent them by maintaining high reservoir pressure. Depletion of the reservoir will make some secondary gas cap above the oil. This gas cap will take the acid gases out of solution like CO2 and H2S, as we illustrated earlier, and it will promote more scale depositions. And also restrictions should be avoided in the condition. For sulfate scales, the main action is to remove the sulfate ions from the seawater injection. You can use some aquifer water just to support your water injection. If you are planning to pump seawater inside the formation to support the reservoir pressure, you can pump some aquifer water, which is compatible with the formation water before seawater injection. This methodology is presented in SK paper, which is applied in Aramco in
Engineer Muhammad, actually, we lost the sound. Okay, sorry. So I think the instructor will rejoin now. Okay, so now we will apologize for all the participants. I think that Engineer Muhammad has an issue with the connection to the internet. Okay, so we would like to thank all the attendees for their time attending this session, and we will try to have a second part for this session to complete this interesting topic about scale management. Okay, so I would like to thank you all again for your time, and also I would like to thank Engineer Muhammad for his time to prepare for this session. Also, I would like to remind you that if you would like to have a certificate for this webinar, you can fill into the form that will be sent into the Zoom chat. Okay. Also, I would like to mention that we have already a running workshop for the integrated production modeling that will include reservoir modeling, well modeling, and production surface network modeling. Okay, so if you would like to enroll for this workshop, you can fill into the form that will be sent also into the Zoom chat, and also we will send a link for detailed content for this workshop. So at the end, thank you all and hope you good night,
السلام
inshallah.
عليكم.
Assalamu alaikum.